So a function is an expression involving an independent variable x and a dependent variable y. The independent variable is inserted into the expression to produce an output, which is our y. So we have x, and we have some function that adds 7 to our independent variable x. So that gives us an output of y, which is equal to the expression x plus 7. So the adjustment to the value of our independent variable x is what our original function does here. So an inverse of this would be a function that undoes this effect to give us back x. So an inverse function is a function that will undo the original function to produce an output that is the original input. So the original input was x. Function number 1 adds 7 to x to give us x plus 7. And now a second function subtracts that 7 to give us back our x. And since we wind up with the original input, that lets us know that function number 2 is the inverse of function number 1. And function number 1 then is the inverse of number 2. So these two functions would be inverses of each other since they undo each other. Let's say x was 25, and we insert it into function 1, which is the square root of x. So the square root of 25 would give us 5. So how would we get back to the original input 25? That would require us to square the 5. 5 squared would give us 25. So we are back to the original input. So function number 1 would then be the inverse of function number 2. And function number 2 would be the inverse of function number 1. So f of x would be equal to the square root of x, could represent this function. And the second function, g of x, would be equal to x squared. And we see that g of x and f of x would undo each other. Another way we could represent this is f of x is equal to the inverse of g of x. This -1 between the g and the parentheses here lets us know that this is the inverse of the g function. And for g of x, that lets us know that g of x is equal to the inverse of f of x. This function is the inverse of this one. This function is the inverse function of this one. So this would be our notation. The inverse function of f is pronounced f inverse of x and is denoted with -1 between the f and the first parenthesis. Now note that this -1 is not an exponent, so do not confuse f inverse of x with 1 over f of x. Okay, the notation for inverse is not an exponent. Two functions that are inverses of each other will reflect across the line y is equal to x. This shows that each point with the xy coordinate in a function has a matching yx in its inverse function. So what does this mean? Let's say we have a coordinate plane. The line y is equal to x. Each of our quadrants is 90 degrees. This line will go at a 45-degree angle. So it will split quadrant 1 in half, and it will split quadrant 3 in half. So along this line you'll have the point 1, 1, 1, 1, 2, 2, and so on. Y is equal to x. So however far you travel along the x, you travel an equal distance along our y, giving us this line that splits the two quadrants in half. So this is our y is equal to x line. So let's say we have a function f of x here. It starts at 0 and it curves up. The inverse of f of x would reflect across this line. So this would be the inverse of x. So when you're looking at the graph of a function, you will know that a second graph is the inverse if it reflects across this line. And we'll discuss a little bit further why this is. Let's say we had a different function, f of x, and it is a straight line. The same distance from y is equal to x to f of x. You produce a mirror image by traveling the same distance from that line. So let's say there is a point along f of x, negative 1, 3. That means on the inverse function, there is a point that exists where you reverse these 2 points. So we go from xy to now the point on the inverse function. The x-coordinate has a value of the original y. So here is our inverse function. This x-coordinate 3 matches the original y. And the y-coordinate, negative 1, matches the original x, negative 1. So we swap the x and the y, and that gives us the equivalent point on the inverse function. Let's say we had another point on f of x, 0, 7. That means there is a point on the inverse function. We switch the 7 and the 0, and that would give us 7, 0. If we have a point along f of x that is negative 7, 0, that means we have a point along the inverse function that is 0, negative 7. Now let's discuss the concept of one-to-one functions a little bit further. A function must be considered one-to-one or an injective function for it to have an inverse function. Examine the ordered pairs or graph of a function to determine if each y value is unique. So the concept of a function being one-to-one is tied to the idea that each input value, or each x, is attached to a unique y value. So let's say we had a set A, which is a set of ordered pairs, and the first ordered pair is 0, 3, the second ordered pair is 1, 4, the third ordered pair is 2, 5, and the fourth ordered pair is 3, 6. And if we examine the points a bit further in this set, we notice that each y value is unique. The first one is 3, the second one is 4, the third one is 5, and the fourth one is 6. So since each y value is unique, that lets us know it's one-to-one, which means the inverse does exist for A. Let's say we had a second set of points, B. The first point, 0, 3. The second point, 1, 4. The third point, 2, 3. And the fourth point, 3, 6. And the y value of 3 is not unique. It's attached to an x value of 0 and an x value of 2. So since the same y value pops up twice, that lets us know that this is not one-to-one. So there is no inverse that exists for this function. So if you're looking at the ordered pairs, you want to look to see if a y value occurs twice. A function is one-to-one and has an inverse function if a horizontal line cannot intersect more than one point anywhere along the curve. So let's say we have our function f of x, and this is the line that represents f of x. And we have our y is equal to x line. The inverse function, if it exists, will reflect over this line. So let's use a horizontal line test on f of x to see if it crosses more than one point anywhere along the line. And we see that if we use a horizontal line, at no point can it cross more than one point at a time along this line. So since that is the case, that lets us know that f of x passes the horizontal line test, which means the inverse will pass the vertical line test. And this is important because the inverse function, like any function, must pass the vertical line test to be considered a function. So we're using the horizontal line test because once we reflect this function across y is equal to x, we will now use a vertical line. And we see that because the original function passed the horizontal line test, the inverse will now pass the vertical line test, and that makes the inverse a function. So the inverse function does exist. So this is why we use the horizontal line test. It helps us determine that the inverse will pass the vertical line test and thus will be a function. Let's take a look at a different f of x. This is more of a x cubed type of curve. So if we use a horizontal line on this f of x, no point along the curve will this line cross more than one point. So since f of x passes the horizontal line test, that lets us know the inverse will pass the vertical line test. So this would be the curve of the inverse function. And if we use a vertical line, we will see that it passes that test as well, which lets us know the inverse is a function. And we see f of x and the inverse of x reflect each other across y is equal to x. So this is what a function reflecting across y is equal to x would look like. Now let's take a look at a function that would fail the horizontal line test. So a parabola representing a quadratic function of some sort. If you draw a horizontal line, we see that it will cross 2 points at the same time, letting us know that this f of x fails the horizontal line test. So if we fail the horizontal line test, if you reflect this function across y is equal to x and draw the inverse function, that inverse function will fail the vertical line test. And if a function fails the vertical line test, which means it does not have unique y values, this y value is attached to this x coordinate, and so is this y value, which means this inverse is not a function. So we use the horizontal line test on f of x to determine if f of x is 1 to 1. If it is, then the inverse function does exist. And if f of x is not 1 to 1, then the inverse function does not exist. So let's walk through an example together. Determine if the function is 1 to 1 by graphing. And we're given f of x is equal to 5x plus 7. So we want to graph f of x and then use the horizontal line test to determine if it is 1 to 1, and thus if the inverse function exists. So if we have f of x is equal to 5x plus 7, step 1, we want to evaluate f of x with 5 different input values. So we'll try to use -2 to +2, but depending on the function we're given, we may want to switch that up from time to time. But for now, I'll try to use -2 to +2 as the input values. And then step 2, we'll record the input and output values from step 1 in a table of values. So starting with the input of -2, f of -2 is equal to 5 times -2, which would be -10. And -10 plus 7 is equal to -3. So the input is -2 and the output is -3. Now we insert -1 for our x, showing us that f of -1 is equal to 5 times -1. And 5 times -1 is -5. And -5 plus 7 is equal to +2. So the input is -1 and the output is +2. And now we insert 0 for x, showing us f of 0 is equal to 5 times 0, which is 0, plus 7, which gives us an output of 7. So the input is 0 and the output is 7. Now we insert +1 for x, showing us f of 1 is equal to 5 times 1, which is 5, plus 7 will give us +12. So the input is +1 and the output is 12. And then lastly, we insert 2 for x, showing us f of 2 is equal to 5 times 2, which is 10, and 10 plus 7 is equal to 17. So the input is 2 and the output is 17. So now, step 3, we want to plot the points from the table of values on a coordinate plane. So we'll take these points and plot them. So our first point is -2, -3. Our second point is -1, +2. Our third point is 0, 7. Our fourth point is 1, 12. And our fifth point is 2, 17. And now with these 5 points, we have enough to sketch our f of x, which is this straight line. So now that we've drawn a straight line through the points, step 5 is to use the horizontal line test. And when we do so, we see that this line will not cross more than 1 point at a time anywhere along the curve. That shows us that f of x is 1 to 1, and f inverse of x does exist. So that is how you go about proving a function is 1 to 1 by graphing. Let's now have you complete a few practice questions. Determine if the function is 1 to 1 by graphing. Question number 1. F of x is equal to -2x minus 4. Question number 2. G of x is equal to -x squared plus 1. And question number 3. H of x is equal to 2x cubed minus 3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1. Evaluate f of x with 5 different input values. So we are given f of x is equal to -2x minus 4. So we'll insert -2 up to +2 for x. And then step 2, we'll record the input and output values from step 1 in a table of values. So for -2, we get f of -2 is equal to -2 times -2, which is +4. And 4 minus 4 is equal to 0. So the input is -2 and the output is 0. For -1, we get f of -1 is equal to -2 times -1, which would give us +2. +2 minus 4 is equal to -2. So the input is -1 and the output is -2. The third point, f of 0 is equal to -2 times 0, which is 0. And 0 minus 4 is equal to -4. So the input is 0 and the output is -4. For f of 1, we get -2 times 1, which is -2. And -2 minus 4 is equal to -6. So the input is +1 and the output is -6. And for the fifth point, f of 2 is equal to -2 times 2, which is -4. And -4 minus 4 is equal to -8. So the input is +2 and the output is -8. And now that we have 5 points from along this function, we want to plot the points from the table of values on a coordinate plane. So the first point is -2, 0. The second point is -1, -2. The third point is 0, -4. The fourth point is 1, -6. And the fifth point is 2, -8. And now with these points, we can draw a line through them to create a sketch for f of x. And now that we have a sketch of f of x, step 5 is to use the horizontal line test. So we want to draw a horizontal line at different points along this curve to see if anywhere along this curve we intersect more than one point, and we do not, which means f of x is 1-to-1 and f inverse of x does exist. Let's now have a look at question number 2. For question number 2, we were given g of x is equal to negative x squared plus 1. So step 1, evaluate g of x with 5 different input values. So g of negative 2 is equal, we have negative 2 squared, which would be 4. So negative 1 times 4 would give us negative 4. And negative 4 plus 1 would equal negative 3. So the input is negative 2 and the output is negative 3. For g of negative 1, we would get negative 1 squared, which is positive 1. Negative 1 times positive 1 would give us negative 1. And negative 1 plus 1 would equal 0. So the input is negative 1 and the output is 0. The third point, g of 0 would equal negative 0 squared would be 0. And 0 plus 1 would equal 1. So the input is 0 and the output is 1. For g of positive 1, we get 1 squared, which is 1. Negative 1 times 1 is negative 1. And negative 1 plus 1 is 0. So the input is positive 1 and the output is 0. In the fifth point, for g of 2, we get 2 squared, which is 4. Negative 1 times 4 is negative 4. And negative 4 plus 1 is negative 3. So the input is 2 and the output is negative 3. So from this step, we can actually see that g of x is not 1-to-1 because the y values are not unique. Here, we have a y value of 0 for both x is negative 1 and x is positive 1. We also have negative 3 attached to 2 different input values. So we can see here that g of x is not 1-to-1. We can go ahead and graph this to complete the process. So step 3, plot the points from the table of values on a coordinate plane. When we do so, the first point is negative 2, negative 3. The second point is negative 1, 0. The third point is 0, 1. The fourth point is 1, 0. And the fifth point is 2, negative 3. In step 4, we want to draw a line through the points to show us the sketch of g of x. And now step 5, we want to use the horizontal line test. And when we draw a horizontal line, we see that it is going to cross 2 different points at the same time, which lets us know that g of x fails the horizontal line test. So g of x is not 1-to-1, and as a result, the g inverse of x does not exist. Let's now have a look at question number 3. So step 1, evaluate h of x with 5 different input values. And then step 2, record the input and output values from step 1 in a table of values. So h of negative 2 would give us negative 2 cubed would be negative 8. 2 times negative 8 is negative 16. And negative 16 minus 3 gives us negative 19. So the input is negative 2 and the output is negative 19. We then plug in negative 1 for x. Negative 1 cubed is negative 1. 2 times negative 1 is negative 2. And negative 2 minus 3 is equal to negative 5. So the input is negative 1 and the output is negative 5. We then plug in 0 for x. showing us h of 0 is equal to 2 times 0 cubed, which is 0. And 0 minus 3 is negative 3. So the input is 0 and the output is negative 3. We then plug in 1 for x. 1 cubed would give us 1. 2 times 1 is 2. And 2 minus 3 is equal to negative 1. So the input is 1 and the output is negative 1. And then we plug in 2 for x, showing us h of 2 is equal to 2 times 2 cubed. 2 cubed would be 8. 8 times 2 would be 16. And 16 minus 3 would equal positive 13. So the input is 2 and the output is 13. And now step 3, we want to plot the points from the table of values on a coordinate plane and then draw a line through those points. So our first point is negative 2, negative 19. Our second point is negative 1, negative 5. Our third point is 0, negative 3. Our fourth point is 1, negative 1. Our fifth point is 2, 13. And now with these 5 points, we can draw a line to sketch h of x. And now step 5, we want to use a horizontal line to test if h of x is 1 to 1. And when we do so, we see that nowhere along the curve will this horizontal line cross more than one point at a time, letting us know that h of x is 1 to 1 and h inverse of x does exist.